Welcome to the DIY Honda Garage channel. DTC P24B8-16 indicates an issue in the Evaporative Emission EVAP system's leak check module, specifically relating to the pressure sensor circuit registering low voltage. This low voltage signal triggers the powertrain control module, PCM, to store the DTC as it signifies a malfunction in this critical component. The ELCM pressure sensor is integrated within the EVAP leak check module and is essential for monitoring the pressure of gases within the fuel system. Located near the fuel tank, the ELCM's responsibility is to prevent fuel vapor leaks, ensuring compliance with emissions regulations. If the pressure sensor's output falls below specified thresholds, it indicates potential system failures that can affect vehicle operation and performance. Understanding the significance of this warning is crucial for vehicle emissions control and overall engine efficiency. The error code DTC P24B8-16 signifies a failure in the pressure sensor circuit of the Evaporative Emission EVAP leak check module. The ELCM pressure sensor's primary function is to send data on the pressure of fuel vapor to the powertrain control module, PCM. If the sensor detects lower voltage output than normal, it signals an abnormality in the emission system. The ELCM is physically located close to the fuel tank, allowing it to effectively monitor vapor pressure. This setup is vital for ensuring that any fuel vapor leaks are detected and managed to comply with environmental regulations. Thus, diagnosing this error properly requires checking both the ELCM and associated wiring to assess where the failure occurred. Several potential culprits can trigger DTC P24B8-16. First, a faulty EVAP leak check module ELCM pressure sensor is a leading suspect, as it may not provide correct readings or might output dangerously low voltage levels. Secondly, an open wire in the circuit can cause a break in signal transmission, inhibiting proper function. Thirdly, a shorted wire may lead to voltage leaks or disrupt the normal function of electrical components. Finally, a malfunction within the powertrain control module, PCM, could misinterpret or fail to properly read the signal from the ELCM pressure sensor. Each of these factors must be thoroughly investigated to pinpoint the exact cause of the issue. When DTC P24B8-16 is present, drivers may visually notice the check engine light illuminating on their dashboard, indicating a problem that requires attention. This error can also trigger various performance issues, leading to reduced engine efficiency and power, possibly resulting in rough idling or acceleration inconsistencies. Additionally, there is a risk of failing emission tests due to improper monitoring of the EVAP system, which can lead to compliance issues. Lastly, a malfunction in this system can lead directly to higher fuel consumption, as inefficient vapor management results in lost fuel economy. Recognizing these symptoms allows for timely intervention and repair to mitigate further damage or inefficiencies. For Step 1 in troubleshooting DTC P24B8-16, ensure the vehicle is in the on mode. This allows the onboard diagnostics to initialize and display key sensor data. Utilize the Honda Diagnostic System, HDS, to check the absolute pressure reading of the ELCM pressure sensor. According to diagnostic specifications, the expected value should exceed 331.37 millimeters mercury. If the displayed pressure is lower, it confirms an existing fault that needs further examination. Remember, a reading below this threshold indicates that the sensor is indeed malfunctioning, which triggers the storing of the DTC in the vehicle's memory. Step 2 involves disconnecting the EVAP leak check module ELCM connector, specifically the 8P connector. After ensuring that the vehicle is still in the on mode, proceed to inspect the unit output voltage. Under normal operating conditions, this output voltage should measure approximately 5.0 volts. If the output does not meet this criterion, it suggests a fault within the ELCM itself, indicating the need for replacement or further evaluation. Conversely, if the voltage is normal, it points to issues elsewhere in the circuit, necessitating further diagnostic steps to find the root cause of the low voltage reading. In Step 3, follow through with a VCC6 open wire inspection to confirm proper circuit integrity. Start by having the vehicle in the off position, and then proceed to disconnect both the EVAP leak check module connector and PCM connector A. Locate the VCC6 wire and check for any continuity issues. Under normal circumstances, the resistance should be less than 1 ohm, indicating a proper connection within the circuit. High resistance or an open circuit would indicate a problem, which necessitates repairs or replacements of the affected wiring. An intact wiring connection is crucial for the safe operation of the EVAP system. The fourth troubleshooting step involves examining the ELCMPA wire for any potential short circuits to the ground. Similar to previous steps, start with the vehicle in the off position and keep both the EVAP leak check module and PCM connectors disconnected. During this inspection, there should be more than 1 mega ohm of resistance when checking for shorts. Resistance levels below this threshold signify a problem, either with the wire itself or its connection to ground. Detecting shorts in the ELCMPA circuit is essential since they can disrupt the sensor's signal output, directly affecting vehicle performance and emission standards. The final troubleshooting step is the inspection of the powertrain control module, PCM. If all previous tests yielded normal readings, the concern likely rests within the PCM itself. This module is pivotal, processing information from multiple sensors and controlling various aspects of vehicle performance and emissions. Anomalies detected in earlier tests that do not point towards wiring or the ELCM mean that the PCM's functionality is in question. A thorough inspection will determine if the PCM is faulty or if it can still correctly interpret input signals. If issues are located here, replacement or reprogramming of the PCM may be necessary to ensure the EVAP system operates correctly. Upon completion of all necessary repairs related to DTC P24B8-16, it's essential to perform a final verification process. First, ensure that all previously identified issues have been addressed thoroughly. After corrections, utilize the diagnostic system to clear the DTC stored in the PCM. This step resets the monitoring system, allowing for fresh readings on any potential reoccurrences of the issue. Subsequently, conduct a test on the vehicle's emission system to ensure it meets regulatory standards and performs efficiently. This step solidifies that the repair efforts were effective and that the vehicle is now compliant with emissions regulations. Preventative maintenance plays a critical role in avoiding future DTC P24B8-16 occurrences. First and foremost, regularly inspecting all electrical connections related to the EVAP system is essential. This proactive approach ensures that any signs of wear, corrosion, or damage can be addressed before they develop into larger issues. Additionally, keeping the vapor management system clean and functional helps in mitigating issues with the pressure sensor circuit. Conducting periodic diagnostics checks using the Honda Diagnostic System, HDS, aids in early detection of emerging faults. By committing to these maintenance strategies, vehicle owners can protect against unexpected failures and sustain optimal vehicle performance. In conclusion, Addressing DTC P24B8-16 requires a thorough approach to diagnostic testing. Each component plays a significant role in ensuring the integrity and efficiency of the evaporative emission system, and any malfunction can lead to significant vehicle performance and compliance issues. Understanding the systematic approach to troubleshooting this error sheds light on the importance of every component's contribution. Moreover, establishing strong preventive maintenance practices enhances the overall reliability and durability of the system. Keeping an eye on the vehicle's performance metrics and immediate response to warning signals ensures a long-lasting operation while aiding in maintaining compliance with emission regulations. Please like and subscribe to the channel. See you next time.